In the last lecture, we discussed most of the portion of the probability. Now we will start with the binomial probability. But before getting into this, let's discuss a scenario. For example, if I throw a dice, one dice, so not one dice, if I throw one coin, right? So there are how much possibilities? There are two, I am throwing one coin at a time, right? So there are how much possibilities that there could be head or there could be tail, right? Now if I throw two coins at a time, so there are how many possibilities now? There could be head, there could be tail at the same time. Let's call this head tail, head head, tail head, and tail tail. So at first there are two possibilities. Now there are two for the first one and two for the second coin, four possibilities. Now if I just throw three coins, so now there are how much possibilities? Two for first coin, two for second, and two for third. 8 possibilities. And if I try to list those down, so how can I do that? Head, 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 tail, head, tail, head, tail, head, head. Afterward, head, tail, 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 head, tail, head, tail, and tail, tail, tail. So there are these 8 possibilities. Total 8 outcomes. But if I increase the number, for example, to 4 coins, now it is difficult to list those down because there are 2 into 2, 2 power 4, which is 16. Now there are 16 outcomes. Now if I just started to list those down, that will be very difficult and it will be time consuming, right? So in that scenario, we usually use the binomial theorem. And there are basically 3 conditions for the binomial theorem. There are many 3 criteria. The first criteria is that each trial is independent. That means that none of the trial have any effect on the probability of the next trial. For example, if I get head on the first trial, that will not affect the possibility of getting tail or head on the next trial, right? This is the first criteria. The second criteria is the total number of trials are fixed. For example, if I'm throwing 3 times, 4 times, or 5 times, that is fixed. That will not change. And the last thing is the probability of success and failure will remain same for the trials. And I could call, if I consider case of coin, I could call the head as a success or tail as a success, depending upon the condition. And we will see one example for this. We were discussing the formula, and the formula for this, the probability which we need to find, the overall probability will be equal to NCR into the probability of success power R into the probability of failure 1 minus P into N minus R. So what is it is this? N is total number of trials. R is number of success. P is probability of success. R is the number of success, and 1 minus P is the probability of failure. And N minus R is the number of failures. And for example, if I consider a question to understand this formula, and if I say that, what is the probability of getting 2 heads and 1 tail if the 3 coins are thrown? Okay, so I'm saying that I'm throwing 3 coins. So what is the possibility of getting 2 heads and 1 tail at the same time? So if I just consider the listing method, that there are 3 thrown, right? So possibility is 2 into 2 into 2, which is 8. So if I list those down, head, 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 tail, head, tail, head, tail, head, 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 tail, 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 head, tail, head, tail, and last is tail, 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 right? So the total outcomes are 8. And the required outcomes, which are 2 head and 1 tail. Now see, 2 head, 1 tail, 2 head, 1 tail, and 2 head, 1 tail. So there are 3 favorable outcomes. And the probability will be what is the favorable outcome? 3, and total outcomes 8, right? So this is through the listing method. Because the total number of trials are less, we can list these down. So if I use a binomial formula here, and what is it is a binomial formula? NCR into P power R into 1 minus P power N minus R. And for this, N is 3. And what is R? We need to have 2 heads and 1 tail. If I consider head as a success, that if I getting head, that is success. That means the probability of getting head will be the probability of success, which is 1/2, because I'm considering right now a fair coin. And there is one more thing, fair and unfair. In fair scenario, if I consider a coin, the probability of head and tail both will be equal, which is 1/2. But if I consider unfair coin, the question will itself mention that the probability of getting head is, for example, 1/3 or 2/3. That is mentioned in the question. And if the question mentioned fair coin or fair dice or fair cards, that means the probability, which is actual probability, is fixed. Now, if I consider the head as a success, so probability of getting success, which is head, is 1/2. So I need 2 head. That means R will be equal to 2. And N minus R will be equal to 3 minus 2, which is equal to 1. Probability of success will be equal to 1/2. And probability of failure, which is probability of tail, is also equal to 1/2. So if I use the formula, this is 3C2 into 1/2 power 2 into 1/2 power 1. So this will be, what is 3C2? That is just 3. And into 1/2 square into 1/2 power 1. So that will be 3/2 power 8, 2 power 3, which is 3/8, right? So you can either go with the formula or go with the listing method. There are other method as well. And if you want to see the another method, okay, so if I want to, this is a third way. If I want to find the probability of this scenario, the probability of getting 2 heads and 1 tail. So of getting head is 1/2. The probability of getting another head is 1/2. And the probability of getting tail is 1/2. But for this, we need to see, because they're 2 same, so use the Mississippi, which we use the similar item, identical item, 3 factorial and 2h divided by 2. So that will be 3 into 1 power 2, 3, which is 3 power 8. So you can straightforward go with the probability concept. You can either go with the listing concept, or you can go with the binomial formula. You will get the same answer. Okay, so there are multiple ways, right? We will discuss 4 ways to solve a simple probability. And before that, let's see one last thing, which is about the at least scenario. This at least scenario is very much helpful. And to understand this, this is exactly same as the complement of an event. Like what we discussed, that if the probability of, let's suppose the event A is 1/2, the complement of that, if I present this with this sign, that will be total probability minus that. Every total probability subtract with that will be 1/2, right? So what exactly in at least case we are doing, that to get an idea, just if I give you some basic thing, that for example, if I ask that the probability of getting at least one success. So the one way of doing is that I will see that, okay, probability of one success, probability of second success, up to the probability of last success. So one way is probability of first success, second success, third success to last success. This is one way. Another way is, and the better way of doing is that probability of at least one success will be the total probability, which is 1 minus probability which is restricted. And what is restricted case here? That probability of getting no success. Because in actual, the total probability is always equal to 1. So if for example, the actual at least probability answer came out to be 0.7. So if you move from inverse, you get 0.3. If I subtract from 1, you will get 0.7, right? So this was the idea, that whenever you get the at least case, that is very much difficult and a lengthy procedure to solve by normal way. For that, you need to consider the restricted case and subtract from total, you will get the at least scenario. For example, let's solve a question for this, that I say that if we roll one fair die, fair 6-sided die, 5 times, what is the probability that we will roll at least 1 time 5 on top? So this is a very simple question. You're asked that you're rolling a 6-sided, fair 6-sided, right? That's mean the probability of each from 1 to 6 is 1/6. You are rolling one fair dice 5 times. So question is, what is the probability that you're getting at least 1 time 5 on the top, right? Okay, so if I solve this with the conventional way, so how can I do that? The probability of getting 1 time 5, okay, the probability of getting 2 time 5, probability of getting 3 time 5, probability of getting 4 time 5, probability of getting 5 time 5, and probability of getting 6 time 5. I need to add all of these. If I quickly use the binomial formula, and considering the success is when I'm getting 5 on the top. So the formula is NCR into P power R into 1 minus P power N minus R. So if I consider getting 5 on top as a success, that's mean in this N is equal to 5, R is equal to, in first scenario, R is equal to 1. And okay, 5C1 into 1/6, the probability of success for getting 5 on top, 1 into 5/6, which I got by subtracting 1, which is 4, right? This will be give the probability of getting 1 times 5. Now 2 times 5, this will become 5C2 into 1/6 power 2 into 5/6 power 3. So if you move further, you will solve for this, solve for this, solve for this, and solve for this. And last, you need to add all of these, which is a bit lengthy procedure to be done. So why not do this a bit quickly? And we need to have at least 1 times 5. That's mean we can do this 1 minus total probability minus probability of getting no 5 on top. So that is 1 minus. Now, if I want to use the binomial formula here, how can I use that? NCR into P power R into 1 minus P power N minus R. In this, what is N? N is equal to 5. What is R now? R depends that whether I'm considering, and for example, if I consider 5 getting 5 as a success, so that's mean the probability of getting success will be equal to 1/5, and probability of getting the failure, which is 1/6, sorry, 1/6, this is 5/6. And for this, R will be equal to 0 and R will be equal to 5. So let's use this formula, that is NC0, N is 5, 5C0 into 1/6 power 0 into 5/6 power 5. So this will be 1 minus, what is 5C0? That is 1 minus 5/6 power 5. So this is exactly same what we get from the upper scenario. But in the upper scenario, you need to add all of these. But in this scenario, you just need to see the restricted case and subtract from total probability, which is 1, you will get the at least case. Okay, now very important thing. Let's see 4 methods to solve usual probability question. Okay, two methods are based on combination and 2 methods are based on probability. Okay, for this, let's consider a question and we will proceed further for solving that question. And for example, if I consider a question, and we will solve each question using 4 ways. If I consider a question that there are 5 employees in a company, including A and B. So A and B are 2 employees out of 5 in a company. And if 2 employees are to be chosen, if 2 employees are to be randomly chosen, what is the probability that the committee formed will include both A and B? Both A and B at the same time. Okay, the question is very simple, that we have 5 employees in a company, including A and B, 2 employees, and we are selecting 2 employees to form a committee. What is the probability that the committee formed will include both employees A and B? Okay, so there are several ways. Everyone understand the question? What is asked in the question? We are asked to form a 2-member committee out of 5 employees, and the 2-member committee will include A and B, 2 employees out of 5 employees. And we are asked to find what is the probability of making that. Let's see the first method, which is very simple combination method. I call this a combination method. And we have total 5 employees, and we need to choose 2 employees to form a committee. And remember, this is a committee, and in this committee, it doesn't matter that whether A is chosen first or B, the order doesn't matter in this, right? Unless I specify that the first person is for the president and second is for the vice president, right? In this scenario, the order will matter. So what are the total outcomes that I'm choosing out of 5C2, right? These are total outcomes. Now, what are required are favorable outcomes. I need to form a committee having only A and B. There is only one way of making that, right? So if I find the probability, that will be 1/5C2, which is 1/10. Right? This is first method in which I simply use a combination method, combination formula. The total outcomes are, the total possibilities are 5C2, and the required outcome, the favorable outcome is only one. Only one committee will include A and B at the same time. So that will be 1 in the numerator, which is the favorable outcome, and total are 5C2, and in short, the answer is 1/10. This is the first combination method. Now, if I see the next method, I call this reverse combination method. That at first I am directly finding the methods of getting a committee including A and B. Now, if I consider a case and if I include all of the rest scenarios and subtract from the total, I will also get the required probability. So again, n is equal to 5 and r is equal to 2. Now I'm doing what? Probability is 1 total minus probability not having both A and B at the same time. So now tell me, if I want to make a committee in which I can't include both A and B at the same time, then in how many ways I can do that? In first scenario, I consider that A and B both are not included. The second one is A is included, but B is not included. And the last one is B is included, but A is not included. So these are 3 possible ways I can form a committee in which A and B are not included both at the same time, right? Now, if A and B are not included at the same time, in how many ways I can do that? In total, there are 5, right? But I exclude A and B. Now there are 3 remaining, and for this, I am choosing 2 members out of 3. This is the first total combinations of selecting 2 members for a committee out of 3 such that A and B are not included in that. The second one is A is included, but B is not included. So if I say A is included, that's mean the probability of that is 1 because A is already included in that. Now, from how many I will choose the second one? I will choose from the remaining 3 because why I don't include 4 here? Because if I include 4 here, B is included but I exclude B because I'm not included B in the committee. This first one is 4, I'm included A in the committee, and this 3 is 4 because A and B are not there. Now for the rest 3, I need to choose one. So this will be 3C1. And likewise, the third one, B is included. For the B, this is 1, and 1 member need to be chosen next. So that will be 3C1, in which A is not chosen. So the total combinations for the restricted case will be P is equal to total probability is equal to 1 minus 3C2 plus 3C1 plus 3C1. And what are total outcomes or total possibilities? Those are just 5C2. So this will be P is equal to 1 minus 3 plus 3 plus 3 divided by 10. So this will be P is equal to 10 minus 9 divided by 10, which is 1 over 10. Right? So you want to understand this, what I did here. At first, we just do this by simple combination, by directly finding our relevant outcomes. In the second method, we did by reverse. We just counted and gathered the excluded or the restricted cases and subtract those from the overall to get a required probability. Now let's see the third method. And that is by simple probability. I call this a probability method. In this method, actually we are making a committee in which we need to select A and B at the same time. So if I select first member, so in how many ways I can select that? In 2 ways, whether A or B, right? And how many total outcomes are there? How many total possibilities? Out of 5, right? So in first way, I have 2 options out of 5. Now 1 is chosen. Now I have only 1 option out of how much? Out of 4, because 1 is already chosen and this is without replacement case. So this is 2, this is 2. So this will be 1 by 10. This is simply straightforward case. You have 2 options, A and B. So first one, you can choose either A or you can choose either B. So that's why 2. And out of 5, the total 5, this is the probability for the first. And for the second, because AND case, you need to multiply. And for the second, there's only 1 option remaining. And the total will be 5 minus 1, which is 4. So this will be simply 2 over 5 into 1 over 4, which is 1 by 10. This is understood by all?
Yes, Faizan.
And the last one is the reverse probability method. What we did in the combination, we see the restricted case. Now we will see the restricted probability case. And the fourth one is reverse probability method. In the reverse probability method, again, we will see the restricted cases and try to come up with their probability. And in last, we will subtract the total with the total. So how can we do that? We will subtract our total. Okay, the first thing. Now, second thing is, if A and B not included. So in how many ways I can select the first person of the committee? I can select that in 3 ways, 1%. And out of how much? Out of 5. Because why 3? Because A and B are not included, right? And for the second one, now I have 2 options out of 4. This is the first one when A and B are not included. Now the second scenario, if A or B are at the first position, if I select A, that is first position. If I select B, that is at the first position. So that will be 2 out of 5 ways of selecting A or B. And the second position will not include A or B. So that will be 3 by how much? 3 by 4. And the last one is when A and B are the second position and the first position is the other one. So this will be 3 by 5 into 2 by 4. So just add these. So this will be 1 minus 3 by 10 plus 3 by 10 plus 3 by 10. So this will be 1 minus 9 by 10. So in short, probability is equal to 1 by 10, right? So you can come up with any way. You can straightforward use a combination or in reverse combination using restricted cases, or you can come up with a probability or with the reverse probability, whatever the scenario suits you best. But it depends from scenario to scenario. In some scenario, it is better to see the restricted, but in some scenario, it is better to straightforward use a combination or the probability formula. And let's see the another question to get an idea about the method. If I say that there are 4 married couples, and if we select 3 person out of these 8 people, 8 because of 4 married, 4 into 8 people, what is the probability that none of the selected, that none is married, that none of 2 are married to each other, that none is married to each other? Okay, this is again a simple question in which you have 4 married couples and you need to select 3 people out of those 8. So what is the probability that whatever person you are selected, none of them are married to each other? This might seem a tricky question, but let's try to figure this out, what is actually happening here. The first one method, let's use a combination method here. So how can we do this? For combination, what are total outcomes? From 8, we are selecting 3, right? These are total. And what are favorable outcomes? Now let's think that you need to select 3 out of 8 such that none of them is married. How can we do that? Let's try to do this way, that we have 4 married couples and we need to select 3 people out of those such that none is married. So if I do this way, that if I select 3 married couples out of 4, so that I can select 1 from each of that, so that will be very sure that none of them is married. What I'm saying that at first I am choosing 3 couples out of 4, and now I am choosing 2 from each of the couple. This is first couple, this is second couple, and this is third couple. What is actually happening here? That this is for selecting 3 couples out of 4, right? So now we have just figured out 3 couples now. And from each couple, what is a way of selecting 1 person? That is 2, that is 2, and that is 2. Just multiply these. You will get the total favorable outcomes such that 3 persons are selected and none of them are married. So now just use the probability formula. That will be, what are favorable outcome? 4C3 into 2C1 into 2C1 into 2C1 divided by 8C3. And again, which is 4 into 2 into 2 into 2 divided by 876 divided by 3 factorial, which is 6. So this will came out to be 4284 by 7. Second method is, if I say a reverse combination method, in which we will see the inverse cases. Reverse combination. And in this method, total outcomes are how much? Those are 8C3. And what are restricted outcomes? By restricted, I mean that the question actually asks that there is no couple, but if I incorporate the couple, that will be restricted part, the restricted outcomes. So what are the restricted outcomes? How can I do that? I can do this way because we have 3 people. That means in a couple form, there are only 2 people. So that if I straightforward select one whole couple out of 4, and for the rest, if I just select out of 6, will this be the restricted outcome case? What I'm exactly doing here, at first I am choosing one couple out of 4, right? So I've chosen one couple. Now there is only one person remaining. So I have 6 options to choose that person. So this is straightforward, the restricted case. So what is the probability here? That will be probability 1 total minus the restricted probability. So what is the restricted outcomes? 4C1 into 6C1, and total outcomes are 8C3. So this will be 1 minus 4C1 is 4 into 6 divided by 8 into 7, because 6 will cancel out. So this will be 2, 2, 3, 3 by 7. This will be 1 minus 3 by 7, which is 4 by 7. Right? So I even got the second method, in which I do this way, that I select the one whole couple out of 4. So 2% already selected which are couple, and the rest I have 6 options to choose one person. So just I multiply those, you will get the restricted case, and straightforward subtract with 1, so that the required probability is 4 by 7. Now see the third part, the probability. The probability way, how can I do that? Just like someone said earlier, that we need to select 3, right? So out of 8, I can select any person at first. So there are 8 ways and total 8 ways, right? That means I just choose one person at first. Now for the next, I have 6 options available. And someone might ask, why not 7? Because if I include the 7, I include the person who is a couple of this, right? So there will be 6, now left with 7. Now I've left with 4 options, and this will be 4 by 6. So just multiply this. What is the answer? This will cancel out, this will cancel out, and this is 4 by 7. This is any person selected. This is excluding one couple. So that will be 7 left, excluding one person, so that we are left with 6. And now this is 5 minus 1, which is 4, is 4 by 6. So there are always multiple ways to solve a question. All you need to understand. Okay, so let's move to the probability. Wow, we can't complete this today. Okay, let's start it with very basic question. Just quickly solve this. You have only 1 minute. There are 20 colored pencils in a pencil string. Okay, so total we have 20 pencils. The probability of choosing a yellow pencil. Okay, we are choosing a yellow pencil. The probability means yellow out of total. That is 0.8. I can write 0.8 as 8 by 10. I can also write this as 16 by 20. Will this make any difference? No. So that's mean we have yellow, total yellow of 16, and others other than yellow are 20 minus 16, which is 4. On the question say the probability there are 6 yellow pencil without eraser. So total we have 16 yellow in which we have 6 without eraser, and we have remaining 10 with eraser. The question is, what is the probability that a yellow pencil is chosen? This is where the person who get 1/2 got the question wrong. The question is not asking about the total. The question is asking that out of yellow pencil. So now the total scenario is yellow pencil, which is how much? Which is 16. The question is saying what is the probability that yellow person is chosen that has an eraser? So how many yellow pencil has eraser with them? 6. 6, 10, right? So this will be 5/8. The mistake you did, you choose 20 here, but the question says the probability of a yellow pencil chosen. If the question is the probability of the total pencil, what which of the them has a erasers with them, then in that scenario you can choose 20 here. But in this scenario, question is just saying that you need to choose out of total yellow pencil such that the chosen one has eraser with that. So that's why you have total 16 options, and out of them 10 has eraser with them. That's why this is 10/16, which is 5/8. Okay, just quickly do this. Be quick. Simple question. The question is saying that if you roll a one fair 6-sided die, what is the probability that the number is even? So what are the possible even outcomes in this? 2, 4, and 6. That's mean 3 outcomes. And less than 4. So in how many ways we can less than 4? That is 1, 2, and 3. Again, 3 ways. The question is saying what's the probability number is even, or this is OR case. If you remember OR case, if I say probability of A or B, that is probability of A plus probability of B minus probability of A and B to remove the overlapping part. So what is the overlap here? 2 and 2, right? So what will we do? So what is the answer in this question? That will be, if you draw the simply Venn diagram to make it simple, in total we have 3 options, 3 options. 1 is overlap, so 3 minus 1, 2, 3 minus 1, 2. So total we have A or B case, 2 plus 2 plus 1, 5, and total options are 6. So our probability is 5/6. In probability, visualizing through Venn diagram is very helpful in most of the scenarios. In scenarios like whenever you are having OR case, AND case, in that scenario, through Venn diagram, your things will be a bit clear and easier to be understood. 10 numbers, 1 to 10. Okay, just quickly solve this question. Somebody is saying 3/4. Okay, in this question, we have 10 balls, 1 to 10. If 2 balls are selected from the bag with replacement, right? What is the probability that at least one of them is an even numbered ball? Okay, so how can we do this? Yes, the answer is 3/4. We are selecting 2 balls with replacement and at least one of them. Now see, there's at least case. Whenever you see at least case, straightforward, in most of the cases, go for the restricted case, right? So to solve the restricted way, now how can I do this? What are the possible way? Yes. What are the possible way I can select the first one? 5. Because there are 5 even and 5 odd. I'm considering a case in which there is no even, right? So this is what? 5/10. This is for odd and this is for total. Into, again, this is 5 and again this is 10 because this is with replacement case. So this will be 1 minus 1 over 2 into 1 over 2, which is 1 minus 1 over 4, that is 3 by 4. Got the point?
Yes.
One way this total possibilities are odd, 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 even, even, and even odd. One way is just do this one and subtract from total. The other way is just consider these three, solve for these three. You will again get 3 by 4. I just go with the inverse method by just excluding the case in which both are odd, and I will get the answer 3 by 4.